Hi, everybody. Thanks for coming, and hope you've been enjoying the Cloud Native Storage Day thus far. My name is Anthony Lai-Ferrario, Senior Product Manager at Pure Storage, responsible for Cloud Native and orchestrated workloads. So today, I'd like to talk with you about Cloud Native Storage on-premises and in the cloud. So I think a lot of folks probably, have a high-level assumption that cloud means something specific about the location of your workload. What I'd like to talk about is how that's not the case, but how when you think about cloud native storage in the context of both on-premises as well as in the public cloud, you're going to get a lot of the same characteristics, but the implementations are going to look a little bit different. So just to set a bit of the background here, I don't think this image should surprise anyone. I think the only surprising thing was it copied amazingly into the Cloud Native Storage Day template. But basically, what we're seeing at Pure Storage is an evolution from the traditional monolithic application through the virtualization stack that we've heard about, a few people referencing, and now into a cloud world where we're starting to see a scale-out approach, a sort of more of a cattle rather than pets style approach for the individual compute unit. Now, given that you're all at KubeCon, I suspect that's not a surprise. I also suspect that a lot of you are either actively living in this world or attempting to move there. So, cloud native storage then. What does storage have to do with this? If we're now all on the cloud and everything is, stateless and scale out, well, it turns out that that doesn't really work forever. I think the first place we saw containerized workloads start to really explode was in stateless workloads. But the key thing you have to realize about stateless workloads is that it's not that they're actually stateless. They've just offloaded state management to an external resource. So as we start to move into more and more mature Kubernetes deployments, more and more mature container environments, we're starting to see persistence become a major issue. Thus, this group, thus all of our friends back there, thus Pure Storage, thus the whole 9 yards, right? But basically, what we're here to say is, as this persistence becomes a thing, we're starting to see it show up in modern database. We're starting to see it show up in the ports of enterprise applications. We're starting to see it show up as that state that your stateless application was previously leaving out, right? And leaving on some legacy data store, if you will. So here's the hypothesis. The hypothesis is container environments want to consume cloud native storage. They need it to be simple. They need it to be automated. They need it to be elastic, reliable, and shared. Oh, I think I'm getting a clicker. Lovely. So why are these important for cloud native storage? Or sorry, rather for container environments. The simplest answer is, when you look at the compute abstraction that Kubernetes gives you, it's kind of a glorious thing, right? It allows you to provision compute completely independent of the underlying infrastructure, assuming you've configured the underlying, infrastructure to exist at all. You're going to get those compute resources. You're going to be able to scale out your applications, and you're going to be able to support the modern deployment patterns and microservices that you would like to support. What we're saying here, basically, by the term cloud native storage is we need storage to act the same way. We can't have storage that's defined, at a device level and has a bajillion knobs and levers. Your end users, whether you are the end user or there are developers out there consuming your cluster, they need to consume storage in a cloud native fashion. They need it to be simple. They need that automation to be fully in place. They can't be worrying about that. More of the sort of load of developing the application and understanding how it's supposed to be deployed is being put on those guys already. We can't ask them to step all the way down into the traditional infrastructure world and deal with storage as it has been, right? So we need to provide it this way. I'm going to beat a dead horse just for a little bit. Container storage interface has been a huge deal. Obviously, we, just like a lot of other folks out here, have a large number of our customers running on the older flex volume interfaces, but we believe CSI is the way of the future. We're totally on board with it. And if you're going to be connecting your containers, your cloud native storage into your container environment, this is the way you've got to be doing it. I'd be interested if there was another way that people thought, but I'm pretty sure we're close to full consensus on this one. A couple of other things to think about. Just because we've moved into a cloud native world doesn't mean we're not thinking about the characteristics of this underlying storage anymore. It has to be simple, it has to be automated, it has to be easy to use, but you still have to worry about the availability characteristics of that storage. You have to worry about whether it's scalable, right? It would be a bummer if your storage service ran out of storage, right? That end user experience is not a positive thing. It's got to be simple. You've got to worry about the performance. And of course, even though we don't like to think about it, the cost economics is also something you have to consider. So as you're looking at cloud-native storage on premises, as well as in the public cloud, you do need to still consider the business factors that sit behind it to make it useful for your environment. So let's talk a little bit about infrastructure. This is the one that I think a lot of folks in the cloud-native world are familiar with. You can pick your cloud provider, AWS, Azure, GCP, among others. And then on the other side, you've got your compute orchestration technologies, Kubernetes. And I know we're starting to adopt some additional container runtimes, but I'll leave the picture there because everybody knows it. The thing, though, is how does this actually lay out? How do you deal with this? Probably most of you will be familiar with this as well. But the typical concept is you've got an availability zone, right? You want to break up your clusters into multiple availability zones. Now, in the cloud, you're oftentimes limited within a physical region to a certain number of availability zones, and you have to take that into account. I actually flipped the order of the slide, so this will make sense later, but this is similar to a concept that we have in on-premises infrastructure that we refer to as pods. Now, I know that's super confusing, but I'll get to that in a second. However, when you look at the way infrastructure provisioning works inside the cloud, it is fundamentally different. And the reasons why it's fundamentally different are you scale totally differently. You don't get to add more availability zones. The availability zones that are there are what you get. But what you can do is you can relatively easily add compute within that availability zone. So you're able to scale on one axis, but in terms of the number of availability zones or failure domains, you are a little bit more limited. On the other side of the house, we have on-premises infrastructure. So it could either be bare metal, it could be vSphere, Hyper-V, OpenStack, and then again, the same compute orchestration technologies. And I think that's actually the beauty of what we're talking about here with Cloud Native, is that the compute orchestration technology stack stays the same, whether you're on-premises or in the public cloud. And that's where we tie in Cloud Native storage into it, and we get this beautiful experience. But how do you scale the on-premises deployment? How do you think about this in the same way that's going to give you these cloud-native characteristics? First is, I want to call out and define pods. Now, this is not a Kubernetes pod that we're all familiar with, but if you talk to infrastructure guys and they're deploying regular chunks of infrastructure, they'll oftentimes call it this. So I just want you to be aware that's a crossover term. But basically, the way you think about pods and infrastructure deployment on premises is that these pods should be independent failure domains. The pods should be laid out in a consistent way from a hardware standpoint, and they should be designed for horizontal scaling. Now, as I mentioned on the previous one where I was talking about how these public cloud deployments work, in the public cloud you can easily scale an AZ larger by adding additional compute instances, but you can't add AZs. When you're on premises, the opposite is true. It's relatively simple to lay down an additional pod and add an additional failure domain, but you're not going to be able to go in and add more servers. Your 42U rack is as big as it is, and that's all you get, right? So something to keep in mind as you're thinking about this. So let's talk about how storage plays into this and how cloud-native storage fits into this ecosystem. And I hope you don't take the fact that I've got the logo of one of our devices here to imply that this is about pure storage. This is an on-premises deployment, and I'm pretty sure if you talk to any of the other folks back over there after this talk about how to support these types of use cases, they will be able to support or discuss this with you as well. But I'm just using our images because that's what I've got. But basically, if you look, right, the simplest way to do this is to throw up a single failure domain. This is super easy. You don't have to have a bunch of complex scheduling, and you can pretty much support that with one storage offering in the other place. So on premises, that could be a single appliance. If you're talking to a company like Pure, that could be a single deployment of a software-defined storage environment. The comparison here in the public cloud is if you're deployed in a single availability zone with your cluster, That cloud storage, if it's in Amazon, that could be EBS, for instance. That's one that's one storage location. You're all sitting within that zone. The connectivity is fairly simple. Now, as long as you're connecting into these environments with something like a CSI driver, your experience is going to be pretty good. So what happens if you want a little bit more complex of an environment, right? In this case, we're looking at a 2-pod or a 2AZ layout. The difference here is that if you're using the same underlying storage technology stack that you were using in that one availability zone or one failure domain layout, you're going to get a different characteristic from the underlying storage. What you're going to find here is this storage in these kinds of layouts is not accessible across failure domains, right? Now, that's the same characteristic you're going to get on premises as you are in the public cloud, and there's ways to deal with that, which I'll talk about later. But this is a valid deployment pattern, be they 2 pods or 3 or however many you decide to have. As long as your application stack understands the fact that it needs to take care of the storage availability at the application layer through scale out, this is something that's totally doable. And I know I've talked to at least one of you folks here earlier today about a deployment that looks exactly like this. So this is an option for providing cloud-native storage. And as long as you configure your storage classes and you allow your applications to take care of this for you, this is an OK way to go. Now, obviously, there's a layer you could put on top of this which would help, right? If your applications don't like that requirement, right? If you don't have a scale-out database, for instance, and you need the ability to have access to that data on both sides, the next way that you want to look at this is connecting the storage and making sure that storage offering is available in both or all of your failure domains, right? So this is going to look like a replicated storage solution if you're in an on-premises environment, or a spread cluster of software-defined storage. In the public cloud, this could, again, be a replication situation, or it could be a storage backplane service that's available across those zones. Now, in this case, it doesn't have to be mountable storage. This could be an S3 in Amazon type of situation. I'm not trying to say what type of storage you need to use. Just want to make sure you understand how these deployment patterns match with providing that storage availability in the way that you would expect for a cloud-native environment. So to build on this, if you said, well, that's cool, I guess I have access to storage wherever I need it, and if I lose one of my availability zones, I'll be able to persist. Well, what's the real thing we're aiming for here, and how is it what's the dream of providing this cloud-native storage in both on-premises and public cloud environments? So this is the dream that we've got right here. The dream here is you can deploy in one cloud and another cloud, whether that be an on-premises cloud, a public cloud, potentially 2 public clouds. The difference here is not only are we looking at a shared storage plane across those, and you can accomplish that again with replication technologies. You could accomplish that, depending on the requirements that you set up for your application, you could accomplish it with failover and data migration technologies like some of the folks have talked about today. But the thing you're also going to have to look at here that's fundamentally different is you can no longer have management planes which live in one of your clouds. So I think as we move forward, some folks have called out good requirements that we need out of CSI to help us support environments like this. But my argument, if you can see as I've been building it up, is that as long as you're taking the right principles towards providing cloud-native storage, and as long as you're thinking about these deployments, whether they be on-premises or in the cloud, where we're going to get to is we're going to get to a place where deployment of workloads in a different cloud is totally fine, right? Or you could have, whether it's a single stretched cluster or 2 clusters with failover capabilities, you have the ability to preserve business continuity through outages that are beyond the scale of a single cloud, right? So there's a lot of value that we can get here. And I think a lot of folks, my guess right now, and actually I'd be interested to chat with you later, maybe at the happy hour about this, but I think a lot of folks would like to get to an environment like this, but my guess is that most folks aren't here yet. So that's just the direction that we're really trying to go and where we're trying to take the evolution of cloud-native storage on-premises and in the public cloud. Now, let me take a moment to talk about how at Pure Storage we're looking to help out with these kinds of environments. First of all, our product in the cloud-native storage space is called Pure Service Orchestrator. The way PSO, that's the shortening we use, the way PSO works is it takes a number of our underlying systems, be they our block systems, our file and object systems, or our cloud-based block systems, and supports those as a single storage service into the cluster. This is designed to support the use cases that I was talking about before, both on-premises and in the public cloud, if you choose to deploy in either of those different environments. We have a very strong ecosystem. We've got a bunch of our partners and folks we've worked with here today. Basically, just want to call out a few of them, but the idea here is, since we're connecting through standard interfaces, and since we have support for various different cloud environments, we are a good option for you wherever you choose to end up. Now, I spent a bunch of time talking about how you might want to deploy your cloud-native storage. Let's talk about a couple of use cases. And this time again, I've demonstrated this using pure technology, but the concept is the same. One of the benefits of doing a good job deploying on-premises and in the cloud using proper cloud-native storage techniques is you can very easily provision the same application to your on-premises infrastructure as you do to your public cloud infrastructure. Now, if you were not following the right way to deploy that infrastructure, you may not have the same concepts. You may not have those failure domains, whether they be pods on premises or availability zones in the public cloud that you can use to define the application availability that you need. Or you might be connecting through some older standard, or you may not be fully connected through CSI on premises, which would block you from moving your application or redeploying it in the public cloud. Another example of this is, instead of just deploying, what about migration? I know we've had a couple good sessions today on technologies that help you move data. That's something we can help you with too, but really the idea here is, again, a benefit of setting your storage up and setting your environment up the correct way is that you get to consider workflows like this in a way that you wouldn't have before. So how much time do I have? Because I've got a cool demo. All right, this is a shorty. But basically what I wanted to just run a quick demo here is an example of using Pure Storage to support cloud-native storage in the public cloud. So as I mentioned, we have a block storage product now, which is native inside of AWS, which runs behind the same storage orchestration layer that we had in the on-premises case. Oh, okay, I just got a time is out and I started to panic. No worries. So this is really crummy visuals, but basically what we're doing here is we're just showing ourselves connected to an AWS ECS or EKS cluster in Amazon, providing persistent storage, cloud-native storage, through a pure cloud block store device in the cloud. I didn't choose to show the on-premises one because if you thought we couldn't do on-premises, boy, we'd be in trouble. But basically what we've done here is we've gone in, we've listed out, shown the cluster that we're in, we've created a PVC. We're just listing that back so that we can see where that ended up on our underlying devices. And then we'll jump over, show you the fact that we've deployed our storage inside of AWS based on this CloudFormation template. And then we're going to go to the management UI and just take a quick peek to show you that we are indeed providing the same storage experience on premises and in the cloud, which is the entire point of my talk. Assuming this loads, it does load, I know it's the video, but assuming this loads, because that's what I'm supposed to say, right? So what we're seeing here is we've got a pure appliance deployed. Let me go back. I want to stop there. I like that picture better. So what we've got here is a pure appliance running natively in AWS, supporting a cloud-native storage and Kubernetes deployment. All right, that's it. Thank you, everybody.